All right, this is week 13 notes. This week we're talking about functions, which is a relationship between two quantities. So the first thing that we're going to talk about is what is a relation. A relation is a set of ordered pairs. An ordered pair is a set of numbers that go in the x, comma, y format. A function is a certain type of relation where every input is always paired with the exact same output. The input are our x values in an ordered pair. Another term we use is the domain, D-O-M-A-I-N. The output are the y values. Another word we use for that is the range. Here is a group of ordered pairs. The first ordered pair is 1, 2. So 1 is our x, and 2 is the y. The second ordered pair is 1, 5. 1 is our x, and 5 is our y. The third ordered pair is 3, 6. 3 is the x, 6 is the y. And the fourth ordered pair is 2, 9. 2 is the x, 9 is the y. An easy way to remember which is which is it goes in alphabetical order. X comes before y in the alphabet, and x comes before y in the ordered pair. We can display ordered pairs in a mapping diagram. A mapping diagram is this, where we list our x values and we list our y values. We have to be careful the way that we list them. So step number 1 is we're going to put them in numerical order. Step number 2 is we don't repeat any numbers. And step number 3 is we draw lines to show the ordered pairs. Draw lines to show the pairs. So our x values, or our domain, are going to be 1, 1, 3, and 2. So we're going to put them in numerical order. So it would be 1, 1, 2, 3. But we don't repeat any numbers, so we're only going to include one of the ones. So I'm going to write 1. The next one in numerical order would be 2 and 3. So in my x bubble, I'm going to write those 1, 2, and 3. Next is we're going to do our y values, or the range. So we have 2, 5, 6, and 9 for our range. 2, 5, 6, and 9. So in numerical order, it's going to be 2, 5, 6, and 9. They're already in numerical order. There's nothing that repeats. So we're just going to write in our y bubble 2, 5, 6, and 9. And the last step is to draw lines to show the ordered pairs. So our first ordered pair was 1, 2. So from the 1 in my x bubble, I'm going to draw a line to the 2 in my y bubble. My next ordered pair is 1, 5. So again, using the same 1 in my x bubble, I'm going to draw a line down to the 5 in the y bubble. Our next ordered pair is 3, 6. So I'm going to draw a line from the 3 to the 6. And the last ordered pair is 2, 9. So I'm going to draw a line from the 2 to the 9. That is a mapping diagram. Don't forget the steps right here, so you can recreate one. The last thing on this page is to determine if it's a function. Remember, a function is a certain type of relation where every input is always paired up with the exact same output. So here's a way to figure out if it's a function. You're going to ask yourself if every x value or input that is repeated is paired up with the same y value or output. Here's a hint. We have an ordered pair of 1, 2. So my 1 is paired up with a 2. And then we have an ordered pair of 1, 5. So my 1 is repeated, but this time it's paired up with a 5. So the x value of 1 is paired up with 2 different y values. When an x value is paired up with 2 different y values, it is not a function. At the bottom, you're going to write a summary of some important information on this page. One of the trickiest things is to determine if it is a function. So try to summarize how you can determine if something is a function or not. So using this information, go ahead and write yourself a summary of 1 to 2 sentences. All right, so hopefully you guys wrote yourself a summary. If I were to summarize it, I would say that when you have 2 repeating x values, they have to be paired up with the exact same y value. Otherwise, it's not a function. All right, so now we're going to talk about the graph of a function, because we can graph functions. They're ordered pairs. You guys have graphed ordered pairs before. So the graph of a function you can always plot the points. Once you have the points plotted, you can tell if your graph is a function by using what's called the vertical line test. So the vertical line test is if any vertical line drawn can cross your graph more than once, it is not a function. That means that one x value is paired up with more than one y value. So here's some examples of some ordered pairs that we've plotted. So I'm going to draw a vertical line on the first one. Did my vertical line cross the graph in more than one place? It did. It crossed the graph twice. Once right there, and also once right there. So since the vertical line crossed the graph more than once, this one is not a function. Okay, the second graph, I'm going to draw a vertical line. Did my vertical line cross the graph in more than one place? No, it only crossed it once right there. So if it only crosses it once, it is a function. So if any vertical line drawn crosses your graph more than once, it is not a function. The next thing we're going to talk about is something called f of x. F of x is how we say that. F with a parentheses and then the x in the parentheses. F of x is another name for the y values, or the output. And there's one more name for that, the range. So the x values have 3 names, the y values have 4 names. F of x, y, output, and range. What we have at the bottom are input-output tables. Usually you guys have seen them with an x and a y. These ones have f of x instead of y. It's the same thing. So what you do is you plug in. So we're going to plug in the x values. Plug in the x values. To get f of x. So we're going to complete the table. There's 2 tables here. First one says f of x is equal to 3x plus 2. And then we have our table. We have a couple values for x that have already been given to us. X is -2, -1, 0, 1, and 2. So we have to plug in each one of those into our equation to get the bottom boxes, or to get the f of x. So the first one we're going to do is when x equals -2. So we have f of -2 is equal to 3x, you're going to leave that in parentheses, plus 2. And we're going to plug in -2. And now we're going to solve. We follow the order of operations where we multiply before we add. So we're going to multiply 3 times -2, and that's going to give us -6. We're going to bring down our plus 2. So we have -6 plus 2. Those are opposite signs, so we subtract. -6 plus 2 is -4. So f of -2 is equal to -4. So in our box, we're going to put -4. The next one is when x is equal to -1. So we have f of, do it over here, -1 is equal to 3x, going to leave parentheses, plus 2. And in our parentheses, we're going to put our -1. We multiply before we add. 3 times -1 is -3. Bring down our +2. -3 plus 2 is -1. So f of -1 equals -1. So in our box below -1, we're going to put -1. Next one we're going to do is x equals 0. I'm going to do that over here. So we have f of 0. I'm just plugging in that number. F of 0 is equal to 3x, put parentheses, plus 2. In our parentheses, we put what x is, which is 0. Multiply them out. 3 times 0 is 0. Bring down your plus 2. Zero plus 2 equals 2. So when x is 0, f of x is 2. Okay, I'm going to save those last two for you guys to do on your own. We're going to move on to the second table. I'm going to erase some of this to give myself some more room. Okay, my second table is f of x equals -4x minus 10. And we have a couple values for x that are already given to us, -5, -2, 0, and 7. So we're going to start with -5. So we have f of -5 equals -4x, parenthesis instead of the x, minus 10. And in this case, x is -5, so I'm going to plug in a -5 right there for my x. And again, we multiply before we add or subtract. So I have -4 times -5, which is positive 20. And then bring down your minus 10. 20 minus 10 is 10. So f of -5 is equal to 10. So in my box, I'm going to put a 10. Okay, I'll do one more. We'll do f of 0 is equal to -4x, so parentheses, minus 10. And in my parentheses, I'm going to put the 0. So I have -4 times 0, which is 0. And then minus 10, bring down your minus 10. 0 minus 10. If you have 0 and you take 10 away, it is -10. So f of 0 is -10. Okay, what we've done here is we've started to create these function tables. These are ordered pairs. Don't forget, you can pull ordered pairs from a table. So for our first example, that was our function. Our first ordered pair that we got was -2, -4. Our second was -1, -1. Our third was 0, 2. And then you guys did the last two. Same with our second example. Our first ordered pair we got was -5, 10. So once you have your function table, you can easily graph it. Remember how to graph an ordered pair. You move left to right first, and then up and down. So this ordered pair right here, -2, -4, left to right first. So the first number, -2, we're going to go left or right. Since it's negative, we go left 2 spaces. And our second number is -4. Since it's negative, we go down 4 spaces. So -2, -4 would be right here. And then once you have all of your ordered pairs graphed, you can connect them and determine if it's a function by using the vertical line test. At the bottom, you guys are going to do another summary for some important information on this page. Make sure you have the function tables filled out, and make sure you have summaries on both sides of your paper for full credit.